Okay, I guess we'll just begin. Welcome to our first session, first pilot session of the platform stream. My name is Li Huang, welcome. There are people that I've met for the first time. Hope to see you all regularly every month. Okay, before we start, just some house rules so that we know how it flows. We will be taking questions, but only after all presentations are done. So if you have any questions, maybe you can note them down on your phone, and then we can, once we open the floor for questions, we'll come to you with a mic. So just put up your hand when you're ready. And just to take note, this session will be recorded, and after the session ends, we will upload the playback on the Singapore Government Developer Portal. So if you're not on a Telegram chat yet, please join us because you'll get updates on like our upcoming events and when the playbacks are available. So I'll just pause here for a bit. If you're not in our Telegram chat yet, come. I welcome you to scan and join us. For those people who are new to this, to our meetup, right? So Stack Community is an initiative, a community building initiative by GovTech. And this year we're piloting a few streams where our objective is actually to build specialized sub-communities within the various tech domains. So the one that you're here for today, it's very much focused on like platforms engineering. And then we have other streams in data and AI. Yeah, so for the platform stream, it actually happens every second Thursday of the month. If you're a software engineer, you're interested in like developer tools, productivity topics, and like systems resiliency, things like that. We welcome you to join us when there's a relevant topic for you. So for today, this is the program run through. We have 3 speakers who will talk about durable executions, and then the Q&A will start at 8:15, so just bear in mind what the flow is like. And I won't hold you guys up for too long. I'll invite Stephen to open for today's session and actually kind of like introduce the background and all that kind of stuff. Thank you.
Thank you for coming here. First of all, a big welcome, all of you. I see a lot of familiar faces here again. Okay, today's topic is really about resiliency and why is it important. So as engineers, can you imagine the amount of time you need to write code to deal with issues with external systems? Because external systems fail, because the network is down, and how do you deal with retries? And when you retry, how many times do you need to retry? And what about external systems that are not idempotent? All this unnecessary, or maybe I said complexity that you need to deal with, not because you write lousy code, but because of the fact that when you deal with distributed computing or distributed system, is by nature unreliable. And it's tough, it's tedious to do that. And as you have been in the industry long enough, you can see how it has evolved from monolith to microservices, which are becoming more decentralized, and a lot of time you need to deal with external systems. And then with AI, when you call the agent, how long it takes to run, and it comes back, and you spend your token, and imagine it failed, and then you need to spend all the token again. So on and so forth. And why am I talking about this? Because today's topic is really about the engineering aspect of how do we build products that is resilient, but not just that, how do we platformize this approach so that other people can build applications on top of what we have built. So for example, in this talk, I think the first one will be by one of our engineers, Gabriel. So he's one of the lead engineer who built Opus. He'll talk more about what exactly is Opus. Think of it like, in a nutshell, it is similar to N8N, but even better. Yeah, even better. Because it's resilient, it can handle retry and failure. And if any external system fail, it can resume from where it failed. And then what, under the hood, what powers it and how it's developed, and the various challenges that we face along the way and how we overcame them. And we have Tao from Temporal work very closely with us because we are using Temporal as the underlying stack to power Opus as well. And he will talk more about how we work together. And then lastly, we will have Wing Kit, one of our software engineer in GovTech who use Opus to construct some automated workflow and how it helps them make their work even faster and easier to maintain as well. I hope you all will enjoy this talk, and I'll be around, so do reach out if you need someone to have a chat to know more about the work we do and any opportunities that we can work together to collaborate, especially with our suppliers, because we are also looking for suppliers who are open and keen to use our platform products to service agency. After all, in government, we have 100 plus agencies to work with, and there's no way we can help all of them on our own. We believe that to go far, we have to go together. With that, I'll pass the baton to Gabriel. Thank you very much.
Hello. Hello. Thank you, Stephen. Thank you. Now we'll pass the mic over to Gabriel, who will start our session's first presentation.
Hello, hello. All right. Hello. Hi, everyone. My name is Gabriel. I'm a software engineer in GovTech. I work about more than 8 years already, and I work under Stephen. And I think Stephen pretty much summarized what I'm going to share today. Yeah. So today here I am. First of all, in my career, I have actually worked across various systems and projects, and most of them involve some kind of workflows and also integrations across internal and external systems. And this is something that one question that's always pop up. What happens to your workflow when things go wrong mid-execution? So every distributed system faces this. So today, actually, I'll work through why durable execution matters. And how durable execution model like Temporal actually helps to address it, and how Opus builds on top of it. So why durable execution matters? So 3 common scenarios that every engineer has faced. So first of all, unreliable integrations. So integrations not just your APIs and your database connectivity, your file transfer, your third-party services, okay, your internal microservices. Sometimes your state already mutated. And then sometimes, most commonly, your teams will actually try to implement some form of custom retry logic. And then in the end, your codes actually get scattered, inconsistent, or even error-prone. So for long-running processes, it's also very common, especially where like human in the loop is involved, like approvals, your batch job, or multi-step processing. And then sometimes your servers will restart, or you run deployments, and your memory get reclaimed. So traditional processes, they don't hold the state that long. Okay, so your workflows need to be able to pause, to be able to resume when, let's say, especially when your infrastructure changes, etc. So another third common problem is when, let's say, your workflow, you have multiple steps. You have 10 steps in total, and then it fails at step 7. So what do? Your step 1 to 6 completed successfully, and then you want to resume for step 7. So most of the time you think, okay, maybe I have the payload, I just restart the whole thing again. But it's not so simple, right? Sometimes you need to roll back your data. So without the checkpointing, sometimes your team rerun everything, you roll back the data, or you have to build some custom tracking logic to see where's your last state that is being completed. So these aren't edge cases. These are actually the reality. This very normal condition, especially in the distributed systems. So for teams that usually they will try to put together queues, your database, your cron jobs, and then you try to implement some state tracking along with your custom retry logic. And then you need to keep polling for, especially if you need results from your external system, asynchronous results. So as a result, sometimes your code, like I said, it can become very scattered, become very fragile, very inconsistent, and especially in the very distributed system, it's very hard to debug, right? So it's good to have a durable execution model or some kind of framework. So in our case, Opus, okay, I'll share a little bit more what is Opus about. So Opus uses Temporal. So it actually handles the retries, the state persistency, the failure recovery, and asynchronous resume for us. So for Opus, we just focus on our code stays clean and focused. So how a durable execution model like Temporal solve it? So in this example, typically on the left-hand side is how you implement your retry logic. You have a for loop, you iterate through a few times until you get a successful result. Or otherwise, you keep trying, you put a delay, etc. Yeah, it's look kind of messy, right? Imagine you have a SFTP you need to handle for your SQS, your queue, and so on. And different kind of integration, you have different kind of retry logics. But overall, on the right-hand side is how it actually Temporal provide us. You actually give us a declarative retry policy such that you just need to define for your activity what is your maximum attempts, what is your backoff coefficients, and what are the kind of non-retriable error. So for example, some of the long-running workflows, especially like I mentioned, when humans in the loop is involved, like approvals. So your workflow, you have multiple steps. Okay, until you hit a step that you need more approval. So in this case, you need to wait. Okay, and then sometimes before the approvals come back, it could take hours or days. Okay, but in this case, we need the state to persist. You wait for the signal to resume so that your workflows can resume. So for Temporal, they actually help us to persist the state at every await point. So the workflow simply just pause, until you wait for the external input. So the inputs can come in the form of approvals, your callbacks or your timers. So everything is through a signal base. Okay, your signals, once it's been received, the workflow wake up and continues exactly where it paused. So as such, you don't really need to poll. There's no need to maintain your store, to keep track of the state. There's no need for cron job. So this is just two examples of how Temporal actually allows you to do the pause and resume. There's two ways of doing it. On the left-hand side, you're using signals. So signals is a way how you can pause your workflow. So on the approach 2 is called asynchronous activity completion. So for this is a way for you to pause your activity. So for both approach, your workflows can get to pause and then resume when there's a need, there's an external input. So same for both, there's no need for polling, there's no need for state store, there's no need for cron job. Worker resilience. So what if your workers go down? All trigger workflows should not be lost. Yeah, so Temporal servers actually help us to persist all the workflow state independent of your workers. Your trigger workflows are not lost, even if all of our workers crash simultaneously. So the workflow state persists on the server. So even when the workers restarted, they will just pick off wherever they are left off. And those steps that are being completed, there will be a history replay. History replay doesn't mean that they will re-execute the activity again, those past steps. No, it simply just continue where it's left off. So only those states or activities that are failed or they are pending, they will continue from there on. So the durability lives in the platform and not in your code. So having talked so much about how a Temporal or how a durable execution model actually help us, so we actually managed to build Opus on top of it. So allow me to introduce what is Opus. So Opus is a workflow orchestrator you build on top of Temporal that helps governments, agencies to automate workflows, build some business rules with a drag and drop. So pre-connected to a whole of government tools with compliance built-in. So in short, the users can actually use the tools to design their workflows in the DAG, directed acyclic graph, also when using all the pre-built nodes. So the nodes are in the form of activities. So the philosophy behind Opus is configuration over implementations. So the users just need to focus on what is necessary for a workflow. They don't need to know how to implement the integrations behind the scene. So in Opus, we have different categories of activities, or rather we call it the nodes. So we have trigger nodes. Trigger nodes are actually our external systems that trigger the workflow in Opus. So as simple as like API, we have the input node, and or even the FormSG. I'm sure that actually most of you have seen what is FormSG, you're aware of what FormSG is. So these are the nodes that actually trigger the workflows in Opus. Then, of course, then we have the basic nodes. They are the building blocks of Opus, what is needed to build a general workflow. So commonly we have nodes like the API node for you to meet a REST call API, or you need some of the nodes that do some computations, your rules. We have decision table, we have expression, or you need a little bit more flexibility, we have function node, which is actually just vanilla JavaScript. So we also allow people to do file processing by using our extract node, our convert node. So things like you want to extract the text or data from PDF or Excel, and vice versa, the other way around. In your workflow, if you need some file base, and also we have some messaging integration with Slack. And then in the next category, WOG, whole government nodes. So these are actually pre-built integrations of existing WOG products. So the users, they don't have to be worried about how to implement or how to interface. So all they need to do is just to configure. So some of the nodes maybe you are familiar with, like Gov Wallet, for users who have a use case to make disbursement, or they need to transfer files via cloud file transfer. And we also have optical for people who needs like a CMS or a data store, etc. And also the last category, the AI nodes. I mean, right now we are in the hype of AI. So we also try to experiment like implementing our own agents and MCP, etc. Durability beyond execution. So durability is not just about executions. Sometimes you need more. In what sense? So Temporal SDK, they provide a live history query. So you can inspect the state of every activity in a real time during the execution. But because Opus, we actually provide the DAG, how the user define your workflow, etc. So actually on the right-hand side, it's a screenshot of how we map the status from Temporal over the workflow graph that the user has defined. So whether is it completed, is it running, is it failed, it's been highlighted on the nodes, as you can see. So at a glance is visible to all. So the input and output payload for each node is also being shown, as you can see at the bottom. So users can actually troubleshoot or debug or verify what kind of data has been flowing in and out for each activity. This is essential especially for government system, because we need the auditability. Users need to know what exactly happens during a workflow execution. So this is definitely important, critical for our compliance and incidents response. However, because sometimes you need data more than just 30 days or 90 days, understand there's a typo here. So Temporal actually retains the history for all the workflow executed. For those that are completed or terminal refers to workflows that are failed, cancelled, or terminated. Basically workflows that are no longer running. So they only have to retain, I think if I'm not wrong, it's actually up to 90 days, not 30 days. So after this period of time, the history can no longer be queried. So what do we do? Sometimes in government systems, you need data more than just 90 days. You need up to 7 years. So Opus actually, we have our own archival. We archive the data, we archive the history from Temporal, so that our users can continue to monitor and inspect as and when they need. So this is also another screenshot which showed that how we actually list down all the past executed workflows, so even beyond the period that Temporal offers. Okay, some examples of how Opus is being used. So as as simple as you want to calculate your income tax. So in this example, it's just pure rule-based. Oh, sorry. Oh, sorry, give me a second. I think the topic is too heavy. Yeah. All right. Sorry. So as simple as on a use case, like we want to compute what is your income tax. So in this example, we are making use of a decision table, we are making use of a function node. So you just need to feed in this workflow, what is your income? We'll compute your income tax. So in this example, there's no integration involved, a very simple one. Or something more complex that involves more integration with some of the different WG nodes like FormSG, AI bots, Postman, etc. So in this example, it's a resume screening, probably used by HR. So a candidate can submit his resume via the FormSG with his CV attached. So when the submission is received, it triggers Opus workflow. And then this workflow will actually extract the file from these submissions. The file is probably in a PDF format. We extract the text, and then we feed into the AI bot. So AI bot is a WG product. It's an LLM service with RAG. And you can actually ask, with this data, tell me whether this candidate is a good fit. Of course, you need to provide your description of the job. So in return, you actually produce a response to say that, okay, it's a good fit. So if it's a good fit, you can see that there's a switch node that actually branch. Yes, it is a good fit. Please forward to the hiring manager. And at the same time, in parallel, it actually send out a notification via Slack. Or otherwise, we can put a timer, sleep for 1 day before I send out a rejection email. Next, another example. This demonstrates how a workflow can be asynchronous. In government systems, very common when the applicant submits a claims, usually they need to go through multi-level of approvals. Okay, so in this example, this applicant submits a claim, same thing through FormSG, and then it needs to send to the processing officer first. So this information is sent to the processing officer via email, and at this point in time, this workflow will take a pause. It will just pause there. Okay, so the email officer, the processing officer will need to respond to the email, be it approve or reject. And then when he responded, this reply actually triggered a signal to wake up the workflow, and the workflow will resume. And then based on the information that is provided, the status, whether is it approve or reject, if it's approved, then you need to route to another level of the officer, which is the approving officer. In this case, it's also through the email. And again, the approving officers need to take action upon it. So of course, again, based on the response or the reply, then the corresponding email will be sent. Okay, I have a few minutes. I will do a quick demo of what Opus is. Okay, in Opus, we are using TechBiz for the authentications. These are the project levels. So in the project, sorry, I'm not sharing the screen. Huh? Right, sorry. So this is my project, my workspace in Opus. So on the left-hand side, this is all the workflows I can create. And today I'm just going to do something simple. So this is the editor for the workflow on this canvas. So usually we always start with a starting node. So in this case, I have a few options to choose from. I have the input node, I have a FormSG, but for the simplicity of this demo, I'm just going to use input. Then I have options to choose what is my next activity I want to perform in this workflow. Okay, maybe I just want to do a function node. It's just pure vanilla JavaScript. I'm just going to manipulate the data. I want to change, I want to send something else. I put hello world. And then after the hello world, I want to call the API. Okay, I'll just put API node. This is my echo endpoint. I'm gonna put a post. And I want to use a JSON, forward the payload, and then I end it off with a output node. So my workflow is just so simple, right? And then I'm just gonna send my workflow to Temporal. I'm just gonna put some identifier, stack 0101. Okay, seems like it's working. Phew. So on this page, this is a monitoring page for all the workflows that has been executed. Just now, if you recall, I put the identifier, put the stack 101. This is the name of my workflow, my start time, my end time. The status is completed. Cool. Now I want to inspect more. I want to see what goes on inside my workflow. I click on it. So you can see that this is the graph, the exact same graph that I've designed, I've defined earlier. And then now the difference is the nodes are being highlighted as green, meaning to say that these workflow nodes or activities, they have been completed successfully. So for each of the activity, you can also inspect what is the input and output. Like just now, in the function node, I actually purposely changed the output to a hello world. And then same thing for the API is also echo, returns me with status 200. Okay, and this is the payload, the body that I send in. Yeah. So with this, yeah, just a simple workflow. Of course, there are more complex examples that are done by my users. Okay, some key takeaways for my session. So durable execution is not optional, especially if you're building workflows, systems, and then you need to have a lot definitely you will face a lot of unreliable integrations, or you have a long running processes, and then sometimes you need to be tolerance infrastructure failures. Yeah, you need a plan from day one. And you choose a platform or a framework like, Temporal is just one example. So let them handle the hard parts for you. You let them focus on handle the retries, the pause, resume, your worker resilience, or your execution history, all these provided out of the box, so that you just focus on your application logic. Your code definitely will be cleaner. And then lastly, the durability is not just about execution. Sometimes you need to think about what is the auditability about it. Can you do monitoring after that? And then, of course, the archival, yeah, which is actually critical where compliance is matters. Lastly, before I end off, allows me to introduce my team again. Again, my name is Gabriel. I have a few software engineers with me, Justin, Li Ying, and Pei Jin, and I have my designer, Lauren. And this product is led by Sylvia. Yeah. And then that's all my sharing. Thank you.
Thank you, Gabriel. Thank you. Now we'll invite Tao from Tempora to take and together with him, we'll take a deeper look at the engineering behind durable executions.
Okay, so there was a picture of myself, and now I'm here. Did you notice any difference? So what happened to Tao? Anyway, so it's been a great journey so far, and like working with Gabriel and the team and Sylvia, like bring durable execution to GovTech. So my talk is, I'm gonna go back a little bit and talk through some of the basic about durable execution. And maybe let's do a quick show of hand. How many of you have heard about durable execution before coming to today's meetup? I know you, I know you. So okay, not many, right? So it's great. So I'm gonna go through the basics. So hopefully walk away today, you get to know a little bit more. So I'm Tao, again, a picture of me 3 years ago. I'm a staff solution architect of Temporal. I'm based of Melbourne, Australia. Came here like a couple of days ago, and then I'm flying back tomorrow. I've been doing like distributed systems for almost like 12 years. So there's a lot of lesson learned. I joined Temporal because I built something similar in the past for like a pretty big public SaaS company, I made a lot of mistakes and then made a lot of wrong design decisions. So when I came to Temporal, I realized I actually did a lot of the right things. So that's sort of how I got hooked with Temporal. I've been like doing architecture, like engineering management, and just like a lot of stuff in the past. But for today, I'm gonna cover some of the basic durable execution. So as an engineer, you're probably interested in like the fundamental building blocks. We keep talking about durable execution, like it sounds like a magic, but what happens under the hood? What are those basic building blocks to make your application durable and scalable? Hopefully I run a demo, so you get to see some code. And then we're gonna showcase a real world design pattern based on those primitives and some QA, hopefully I have the time. So let's start with a quick intro to durable execution. This is a typical distributed system that you probably get to build or operate these days, right? In order to kind of fulfill order or make some payments, you go through quite a few steps, right? Each of the steps in a distributed like a microservices architecture is backed by a downstream dependency service, right? We all know that when we make those API calls, things can fail, right? So either network failure or maybe the downstream service like become not available or timeout. A lot of things can go wrong. So as an engineer, how do we make sure this system is reliable? We start throwing a lot of the queues. This could be SQS, Kafka, Redis, RabbitMQ. We put a lot of retry logic in there. We have to deal with like, you know, backoff factor, maximum retry attempts. We have cron jobs, we have timers. A lot of the bells and whistles, we call them like a plumbing work. So according to like a DORA stats, and like average engineer could spend up to 70% of their time, like what Steven mentioned earlier, on those boring plumbing work that is not really contributing to your to provide the business value, right? What's worse than that is a lot of those bells and whistles you put into place gonna catch fires, right? So I came from here, I used to carry PagerDuty every day. It's a lot of like sleepless night and like wake up in the middle of something called fire, right? So I have to kind of put on the fire and kind of do a lot of troubleshooting and find the needle in the hay. It's not fun, but this is the reality, right? So we live in this world today. It's pretty painful, and this is where Temporal come into play. We give you a battery-included framework. I should stop saying Temporal. Let's talk about durable execution. So what durable execution brings you is a battery-included set of, it's like a framework, right? There's a lot of building blocks. We're gonna take care of the retries on behalf of you. We're gonna introduce timer as a primitive. We have scheduler to replace the cron jobs. We have queues, observability, and state management. So a lot of those capabilities are being done by choosing, different services from the cloud provider. But now we give them like a holistic, harmonic, like the framework. So how do you make use of those capabilities? We don't introduce a new DSL they have to learn. We give you a set of SDKs, right? So right now we support 7 different languages. Soon we're gonna introduce another one. So we're gonna make a family of SDKs, Java, Go, TypeScript, and Python, .NET. And you just write the code or choose a language that you love. You don't have to learn anything new, but use those SDK to build your application. And you can benefit from the durable execution. You get the reliability, you get the scalability, you get a lot of observability for free when it comes to troubleshooting. Those things are gonna become super, super handy. All right, so let's start with some of the building blocks. The first one, activities. What is activity? Let's imagine you're writing a function, right? The function make an API call to a downstream payment service. You make a request, and it fails. What do you do now? What are the options you have? Do you throw a quick queue at it? Do you write to the database? With Temporal, we actually give you a very simple solution. We put a wrapper around your function. With a wrapper, in place. We're going to intercept the input to the function call. We're going to track the output from the function. Even the exceptions thrown from the function, we keep track of them. Where do we keep track of those state? We actually save those into a temporal server. So we persist the state, let's say, when you call a function, the input of the function is get saved into a database. That temporal operates on behalf of you. Now, if the API request fails, temporal or the durable execution, gonna retry the function call on behalf of you. And there's a whole bunch of retry policy you can put into place, like the backoff factor, the initial kind of retry intervals. But we take care of all of that. You don't have to code them for them, right? Through the retry, hopefully this function call eventually succeed. So this is like the simple wrapper, very basic, simple idea, but from there, there's a whole lot of potential. Now, we talk about activity. What is a workflow? Workflow is a very overloaded term these days. Let's put it like a simple example here. We have a function, right? A function with nested like a child function. So when you call process order, it's gonna go through like a check fraud, prepare shipment, and charge. We already learned that for each of those function calls, you can put a wrapper around it, so now you get kind of a babysitted function. When it goes wrong, Temporal gonna help you to retry and eventually guarantee the success execution. Those data are saved in the temporal server, right? What about this parent function? What if this process order goes wrong? Again, same idea. We put a wrapper around it. And we call it temporal workflow. So now we have all the state from your application get processed on the server side. If anything goes wrong, halfway through, partial failure, we can use the state saved in the server to reconstruct your entire application. What you get is your application becomes durable. This is the crux of the durable execution. Once your application becomes durable, you actually get a lot of benefit. You get crash proofing, you get the queuing system, you get scheduling, you get retry, and you get observability, and a lot more. So Tal, what do you mean by the crash proofing, right? This is kind of a new concept. How do you guarantee your application can survive from crash, right? Let's go through the steps, right? Same process. We start with the order processing. Remember, there's a wrapper around it, right? So we use a wrapper to persist the state on the server side. The input of this order process gets saved on the database as an event. Let's say event 1. We make progress, right? Check fraud that end up as another event on the server side. We prepare the shipment that end up in another event. At this point, your application crashed, right? This could be like EC2 instance get bounced, your container got rebooted, you redeploy your application, everything's gone from the memory, right? But your workflow hasn't completed yet. So there's one more step to execute. What do we do now? Let's say you bring back another application instance, it come back alive, it knows nothing, like a blank canvas, right? Immediately, when the workflow is making progress to the next step, the first thing that the instance, your application instance is gonna do is gonna grab all the events that save on the server side into the local memory. We're gonna kick off a process which we call replay. Sometimes people call it rehydration. We wanna rehydrate the events that previously stored on the server side, and we're gonna run through the code like a fast forward your application code by replaying against the events. Instead of recall the API to check the fraud, we're gonna get the result from the previous execution from the events. Instead of calling the API to prepare the shipment again, we're gonna grab the result from the previous execution events. At this point, we basically rehydrated all of your internal state, including the local variables, back to when it crashed, right? Kind of where previously left off. And from here, we can just keep running the workflow until the end, until you succeed. So the idea here is hopefully start making sense. through replaying the events we are tracking on the server side, we can help you to reconstruct your application state, even after you're losing all the memory. I'm doing that without having you to kind of, interacting with your own database or managing your own database schema. So because Temporal is kind of abstracting that all the way away from you. So that's what we call the crash proofing. There's another primitive, it's called timer. Let's say, we introduce a sleep, a bit of delay in between the prepare shipment to charge. We, as an engineer, we all know there's a sleep, there's a timer in most of the programming languages, but we don't use that for the server-side application because why? When the application restarts, this sleep or timer just goes away, right? What Temporal does is that we shift the responsibility from your application of timekeeping. We shift that to the server side. Whenever we see, if you like register a timer by using the Temporal API, we're gonna make a call to the Temporal server, which means we're actually tracking the timer on the server side. Doesn't matter how many times your application restarts, the time is kept on the server. When the timer fires, we're gonna notify your application. Let's step through the code, right? So process the order, check fraud, prepare the shipment, now we come to the timer. We ship the timer, timekeeping to the server. At that point, the code gonna yield itself, right? Gonna basically block. Wait for the timer to hit on the server. So let's say now the time comes, Temporal server gonna wake up your application, your thread. We call it re-enter into your application execution. We're gonna recover from there, right? Resume the execution and then let the workflow to continue. Again, remember what I said earlier, doesn't matter how many times the worker restarts because the timer is kept on the server side. So we're tracking that on behalf of you. The next one is, I'm gonna like a one stone, two birds. We're gonna talk about signal and await, the two very important primitives from the durable execution. So this time, I'm gonna introduce a new capability to the workflow. I'm gonna introduce like approval process. We call it human in the loop, right? I'm gonna wait for some sort of the local variable, like approved, like let's say it's a Boolean, to change its state from false to true. As soon as the approved, let's say default is false, like change it to true, we're gonna unblock the line of code and consider its approval has been made. How do we update that local variable? Quite simply put, we just put a function around it, right? So we have a function which change the approved Boolean from false to true. How do we invoke that function? We put a wrapper around it, and now we have a signal handling in the durable execution. How do we call the signal? All right, let's step through the code. Start processing order, check fraud. Now I'm waiting for the human approval, like a button click to happen. The application gonna block at that point, gonna wait for someone to click the button. Let's say you hit the approval button, there's a request made into Temporal server. The Temporal server gonna capture the request, gonna trigger the signal. After triggering the signal, we're gonna call the function. Within the function, we're gonna update that Boolean to true. This, in turn, trigger a reevaluation of the await statement. So now, approved, it's got turned from false to true. We meet the condition. Now the approval happened. We're gonna resume application and let it to continue the execution. Prepare shipment, sleep, the timer goes to the server, and eventually takes the charge. All right, there's a lot of other durable execution primitives: query, update, child workflow, schedule, heartbeat, cancellation. When you put them together, you get some design patterns. But before we do that, let me run a quick demo just to showcase the durable execution. It's a money transfer application. So I'm taking the money from one account and put into another account. The dollar amount doesn't really matter. I choose like a random person to deposit $100 into. So I'm gonna run the happy path, right? Now I kick off the workflow. You can see the workflow is running here. It goes through like a few steps. Each of the activity means like an API call, and there's a timer in between just to slow down the process so you can see it actually making progress. Now the workflow completed. I'm gonna run a different scenario. This time, let's say it's a human in the loop. When I kick off the workflow, you can see there is a timer kicked in, right? Within 30 seconds, someone needs to click the approval button, otherwise we're gonna reject the workflow. So the workflow currently looks like this, right? It's paused there, wait for the approval to happen. Now if I click the button, you see on the workflow, there is a like a purple dot that represents the signal. Now the signal in turn calls a function from within the workflow, change the local variable, the workflow can continue from there, right? Pretty straightforward. Now, I'm gonna show you something a little bit special, right? I've got this workflow. As an engineer, sometimes we make mistake. One of the very common, very annoying mistake is like you put a null pointer in your code, right? I'm using Go just to demo. Uncomment my code. I basically have a bad pointer, right? I'm dereferencing a pointer, which is null, right? In Go, that you know that's gonna trigger like a panic. So I'm gonna run this my worker again. And then I'm gonna choose a bug in my workflow. Start the workflow, let's see how it executes. Right. You see here, the workflow failed. Why it failed? Because of no pointer. From within the temporal UI, you actually get to see the runtime error, invalid memory address, or non-pointer defined reference. But at the same time, you see the workflow is still running. It means that the durable execution, it hasn't given up on this workflow execution. So kind of waiting for the engineer to fix the error, right? So how do we go about that? Imagine there's already an API call made, right? So the money has been taken from one account. If you kind of give up, you kind of have to compensate and kind of deal with, clean that up. But with Temporal, you simply fix your code, redeploy your worker. If you just wait on this screen, so immediately redeploy the application, it kind of picked up from where it's left without going through all the previous steps and just continue to run, almost like nothing happened. But if you look at the detailed event history, you see there's definitely failure there, but we treat those like a transient failure. We maintain the application state on behalf of you. We give you the chance to fix up the bug you put into the code. Eventually, we guarantee the successful execution at the end. So this is a little bit of magic when it comes to like saving the life as engineers. I guess the last part, I'm gonna before I wrap up, I'm gonna pick one design pattern. Saga. Anyone actually implemented Saga in your application? You know what Saga is? Like you go through a transaction, distributed transaction. If something goes wrong in one of the steps, you want to wind back that transaction. You want to compensate or reverse what happened in the past, right? It's actually non-trivial. This implement Saga in a traditional architecture is, you think about the queues you have to put into place or a database you have to keep track of the application state. It's a lot of overhead. Imagine this like 4 steps. If it is like 14 steps, 40 steps, right? How do you kind of make sure your application can scale? With Temporal, it's really easy. This is a Saga implementation based on the durable execution, right? Let's go through steps through the code, right? So you enter let's book a trip, right? We build a compensation stack, basically capture all the reversal steps as you kind of progress your workflow. We begin with like pushing a compensation step before we actually reserve your flight. So if anything goes wrong with when you reserve the flight, we can call the compensation from there. We do the same thing for hotel reservation and the payment. Let's say at this point, when you charge the credit card, it's an insufficient fund. So you have to reverse all your transactions. You have to cancel the hotel, you have to cancel the flight. Because we are keeping track of all the cancellation logic in the stack, so at this point, when we come to the track catch block, we basically just run through the last in, first out, a LIFO thing, right? So we pop the compensation function calls from the stack. This time it's gonna be the refund payments. We call the function, the payments got refunded, and we go back to the previous cancellation logic, cancel the hotel, compensate, and again, loop through it, cancel the flight. So at this point, your entire transaction got reversed back. You may think like, I can write this code, I can implement it today, but how do you make this thing durable? How do you make sure it's reliable? How do you survive the application reboot and restart during this transaction, right? So Temporal, like a durable execution, actually make this really, really easy for you. All right, there are a lot more design patterns out there, entity workflow, early return, signal with start, delay start. So I have limited time, but you know what? You can scan the QR code, you can start learning about Temporal. It's an open source framework. We have awesome introduction online courses, like you can take your own time, self-pace it, and we support 6 different languages as part of this online course. Cool, thank you. Thanks so much.
Thank you, Carl. Thank you. So the final presentation for today will be by Winkit, who will talk a bit about durable execution workflows and how it's being implemented in a feature within TechBiz. Over to you.
Okay, so my name is Winkit from TechBiz. Today I'll bring you through one of the features we implemented as part of our subscription workflow using durable execution in TechBiz. Okay, so this is the contents. First, I'll go through what's HTTS and what is TechBiz general about to provide some context. Then I'll go through what the subscription feature that we've implemented in TechBiz, what are some of the requirements and what we needed to do to implement the feature. And then how it will look like without durable execution when we were solutioning the feature. Then implementing the feature using durable execution. And then why we chose to use durable execution and what are some of the lessons learned when doing the entire implementation of this feature using durable execution. So first, I understand that there will be some non-public officers here. So in order to provide context, I'm going to go through what Singapore Government Tech Stack, or HGTS for short. So for those who are not public officers, you guys can actually scan the QR code. It will bring you to a URL that further explains what HGTS is. So basically, it's a set of platform tools that streamlines and simplifies the development process and enables code reuse for the whole of government to build secure and high-quality applications. Some examples are, for example, GitLab applications or Elastic that agencies can subscribe to this HTTS for them to use while going through their development journey. So what is TechBiz? TechBiz is also actually part of the Singapore Government Tech Stack product. Basically, we are a portal that streamlines the onboarding of the HTTS products. So last time, what used to happen is whenever a user wants to use the HTTS products, they have to go to each and every HTTS products they want, and then go through the entire onboarding process with them. And this process can take up to 1 to 2 weeks, depending on the things required. So basically, our portal is like a subscription portal that streamlines this and cuts down the timing required to actually onboard to the HTTS products to about 1 to 3 days, depending on how fast can the users get all the information required. So we also do subscription management. For example, if they require additional licenses or they want to reduce their licenses or they want to actually subscribe to more HTTS products or actually unsubscribe from certain HTTS products because they are not using it anymore, they can do through our portal. And lastly is the consolidated billing. They can see how much they need, the invoicing of how much, what's the cost they need to pay for using all the HTTS products, and all of them are consolidated in TechBiz itself for all the products they have subscribed. And then this invoice will also be used by the government finance team to do all the respective billing and etc. So with this, let me bring you through one of the features that we recently had to implement and is currently in production, which is the feature of trials. So what are trials? Trials is basically a feature that allows users who wants to quickly experiment using certain HTTS products without the hassle of going through the onboarding process, which requires them to maybe get certain information about their agency, what is their billing information needed for billing to happen, and they also might need to get the AOR approval from their director before they can even start using the HTTPS products. So this aims to eliminate the long hassle that they require and allow developers to quickly experiment to see whether certain HTTPS products suits their needs or not. So that is the requirement that I'm going to go through today. So these requirements includes validations. For example, has this user actually created a trial in TechBiz for a particular HTTPS products before? If this user has already created a trial, then probably we should stop them from creating another trial, bypassing them from having a free HTTPS products forever. They can just simply create trials every time it expires. Next is the provisioning. Once the user has requested for a trial, how do we actually ensure that the trial is now ready for them to start experimenting for that short period of time? So this might involve creating groups in the Azure Active Directory for user management, for example, and us as the middleman to the HTTPS products and the user, we might need to send certain information to the product downstream, telling them that, hey, somebody wants to trial your product. This is the information you need to provision them, and please ensure that this user can start using your product. So next is the cleanup of expiry. As you know, trials has an expiry date. Trials is not forever. So basically, when the time to where the trial ends has elapsed, then we also need to handle the cleanup of what we have actually provisioned for the users. So this is the cleanup. And what if the user likes using the HTTPS products and they decide, hey, this is actually good for us. Now we want to convert it into an active subscription in TechBiz. So this is also one of the use cases that we have to handle. So as the previous two speakers has already explained, this is how a traditional architecture that would look like if we want to implement these features using the traditional methods. So in TechBiz case, we have our queue services, the RMQ, which also handles retries. We have our backend microservices, and we have certain cron jobs to do things that needs to be scheduled or there's a timer to it. So the user journey for non-durable execution workflows would go something like this. First, the user requests a trial subscriptions, and then from there, a sort of event will be sent into our queue, which will then be picked up by our backend microservices. So each of these events, for example, validate params or creating trial data, is actually one event chain at a time. Why we don't do it as one single function is because certain of these functions will require some time to actually complete the actions. So we chose this will have to be done in the event base, whereby after an event is done, we resubmit back into the queue to be picked up to continue the next event one by one. And as you guys can know, this is also prone to error, meaning if one event in the chain fails, we have to make sure that it is retriable. And currently in TechBiz, our old architecture without durable execution is to make use of a simple RMQ retry queue. So how our queue works is that we have a message time to live in the retry queue. Anything that fails will first go to the retry queue. After the RMQ messages TTL has elapsed, then it will get sent back to our main queue for retry again. So once we have exceeded the retry attempts, of course there will be a logic to put it to the back queue where you will alert the engineer that, hey, something has failed after all the attempts have passed. This is the time where we, as engineers, have to step in and then debug the issue. Why did it fail totally? Is it because of a bug on our end, or is it our downstream went down? And this causes the user to not be able to continue using the trial. Okay, so of course, with trials, like I mentioned, one of the requirements was that we have to do the cleanup if the trial expires. So how do we track when a trial expires? Without durable execution, what will happen is we will need a cron job that runs either hourly or daily to go and search our DB, which are the trials that is actually expiring today or at a particular time frame. And once we found that the certain number of trials has expired, then we need to go through the same event chain, which is to submit into our queue for processing for removal. And it will apply the same retry mechanism that I've explained before in the previous example. Okay, so the drawbacks. First is the harder debugging. Now, our process is across multiple services. When we actually try to provision a trial, it can be a process from all our microservices in TechBiz, or it can be a downstream service that we have to call. Be it TechBiz Azure Active Directory, or we call the product to send a webhook, or there's a certain endpoint that the HTTPS products wants us to call in order to provision the trial. So now traces are spread across services. It makes things hard for us developers to debug what actually went wrong. Also, long-running processes may cause the APM in Elastic to not be visible, and this causes further strain on us having to find out the root cause. Next is the limited visibility. For a trial that is stuck, how do we know at which stage has it failed? Now we have to search through multiple places. Our DB, we can keep a state, but this state, why did it fail? Did it fail because of a bug on our end, or did it fail because our product hasn't responded back to us? So these are the lack of unified state and the visibility that we will face potentially. Next is the hard to customize. Basically, as I mentioned, HTTPS products is a suite of products that the government is offering, and each product may have their own trial requirements. If we were to cater to each and every product using a common function, it will be very hard to customize to tailor all the product needs. Lastly, RMQ retries are very basic, meaning for a retry queue, I can only set a fixed TTL. For example, 1 hour. If I want to do a variable retries, I have to create multiple queues to handle, and that would mean that I have more things to manage. Lastly, what if I want to do a manual retry? If I want to do a manual retry, it means I have to go to the RM queue, I have to get out all the message in the queue, find which is the message that I actually want to retry. And this is actually quite difficult for those who have attended this before. So how we implemented trial using durable execution. So basically, this is how the durable execution workflow looks like now. First, as normal, the user will submit the trial request. You will then start the workflow, which will run through each steps. The validate parents will be one activity by itself. Doing things like upsetting the subscription admins, the starting of the processing events, and the optional things like sending emails and webhooks are now wrapped around with the durable execution feature with the retries and retriability and failure handling. So this removes the need for us to manage our own RMQ retriability. We can just go through the entire process. And if certain part fails, like for example, let's say when we are starting to process the events, downstream to product, an API call fails, it will automatically handle the retry for us. And that's the beauty of the durable execution. So once a trial, everything has been done on our end and the product ends and the trial is ready for use. So how do we handle the termination case? Basically, we start a long-running durable execution workflow, which is the termination workflow. What will happen is, sorry, the figure is a bit wrong, I'll explain later. So the termination workflow, basically is a long-running process. There will be a timer to it. Basically, what we need to do is 2 things. First, once the trial is near the expiry, let's say the trial is going to expire in 14 days period. So let's say when it comes to remaining 2 days, we actually want to send an email to the user saying, hey, your trial is expiring. If you want to convert, please convert. If not, at the end of the 2 days, we will clean up your trial for you. So that is the near expiry block. If it's not near expiry, we won't do anything. This is a mistake on my end. So we won't do anything. Then there will be another timer that will trigger upon the trial expiry deadline has passed. And when that timer comes, then we will clean up the trial process. So this is how the durable execution works for the termination workflow. So why durable execution? Now, as you can see, what happens is that we're now treating the entire trial feature requirements as a durable workflow. It keeps the workflow state and history in one place, which is in our durable execution UI and database. Then we can also handle timeouts for expiration of trials without the need to implement and maintain cron job schedules or retrying. Then we also can receive signals, like mentioned by Tao previously. For example, let's say a user wants to convert their trial into active subscriptions. Upon receiving such requests and getting all the approvals required, we can do a signal to the termination workflow and saying, you don't need to terminate anymore. Why? Because we have already converted these trial subscriptions into an active account. And lastly, durable execution will help us with the retries and failures. So what else has TechBiz implemented in the durable execution flow to make things better, to make life better for us? So TechBiz have multiple microservices. Each of the workers are deployed as a Nest.js module. So meaning our subscription microservice has its own dedicated worker. Our billing microservice has its own dedicated worker. Next, common activities are actually implemented in the shared library for reusability among all of our microservices. Thirdly, we also have custom interceptors for Slack alerts. When a workflow or activity actually failed, how do we as developers know? So we create a custom interceptors that intercepts errors and checks how many times has it failed. Is it a complete failure or is it a temporary failure? So for example, if a workflow has completely failed, for example, the process hard stopped, then a Slack alert will be sent to our channel and the developers can take action. For our retries currently, I believe it will retry until 24 hours has elapsed. After around 24 hours, if it's still failing, the next time it failed, the alert will also be sent to our Slack. So lastly, for easy identification purposes, because we have already a few workflows in TechBiz, we actually prefix our activities with the workflow name for easy identification, which workflow does this activity belongs to. With this, I'll go through some of the lessons learned. So idempotency for us is key because we need to handle when an activity retries. We need to make sure that when retrying, we do not accidentally introduce duplicate things. Like, for example, let's say we are inserting things to our database. It's important to wrap the database actions with things like transactions to make sure that when there's a failure, we roll back. And if we created things in the Azure Active Directory, if really we need to roll back, we are able to handle these kind of things. Next is to be mindful of long polling patterns. One example I can give is, for example, our termination workflow. Last time we used to do continuous polling at a very short interval, even though the expiry is 14 days. This causes the execution history growth to actually hit the limit, and our termination workflow actually terminated early. So upon realizing this, we have to go and fix to wait to use a timer instead of continuous polling for the timeout to ensure that we do not face this problem. And then there's things like cost involved if you continuously do polling to the durable execution server. And lastly is to really start simple. Try not to worry about whether your backend microservices can handle the loads or is there enough workers to handle everything. Start simple first, implement it. Then in the UAT or staging environment, right before you go to prod, do some checks to see whether is your configuration correct. Is the workers enough for what you are trying to do in prod? Or is your backend microservices downstream able to handle the load that if, let's say, hundreds of these durable executions starts at the same time, can your backend services handle the load? Do you need to throttle somewhere, be it at the workers level, or you need to improve the backend services ability to scale up? Yep. So with this, I conclude my presentation.
Thank you, Winkit. You can remain on stage. Now we'll open the floor for Q&A. So any questions, put up your hands first, and we'll have people pass you the mic. Tao, I'll invite you on stage too, and Gabriel. Okay, nice. Question time. Any questions? If you put up your hand, we'll come over with a mic.
Thanks for sharing. It's quite informative. So the question you have is regarding the example that basically the Temporal platform provide a timer to make the workflow more durable, right? And there's an example showcase as well. So my question is, may I understand a little bit more how the timer help the workflow to be more durable? This part I'm not quite clear after looking at the sample.
Right. So like a traditional timer is not durable at all, right? So if your application restarts, your machine gets reboot, the timer gets lost, right? So Temporal's timer, because it kept on the server side, we maintain that state on the server. So your application, doesn't matter how many times it restarts, we bring the timer back, if that makes sense. Right, so it's a server-side timer, and we guarantee the timer always ticks on the server, so that we take the responsibility away from you, so you don't have to worry about that. Timer itself is not really giving you the durability of your workflow, but it's like a building block inside of the workflow. If you're waiting for something to happen, if you send a reminder after a day or 5 days, you can simply put a timer. Traditional implementation like that, you have to use a cron job, wake up every hour or so, scan the database and look for, whether or not it's time to send that next notification, right, across the database scan. But with Temporal, it's simply like a timer for that particular user or workflow. And then it's a much simpler way of dealing with this, with time. And this is why it's called Temporal. It's related to time, so it's, yeah.
Yep, right here. Hello. Yep, right here. My name is Aman. I'm from Kyndryl. My question is less technical, but more around the concept, right? So what I understood, and I just want to clear my thoughts, right? So I understand that Opus is actually built on top of Temporal. Is that correct?
Yes, you're right.
Right. And Temporal is basically the sort of orchestration layer. Just a question. I'm sure that if you would, so it's two questions there. Number one, what are some of the, if you were to compare Temporal to some of the other platforms out there, what would they be for an apples to apples comparison? That's number one. And number two, why was Temporal actually chosen for Opus?
Okay, maybe I'll answer the second question first. So why Opus choose Temporal? I think the very first reason is durable. The second reason is headless. So I'm sure that you have seen some of the workflow engine products out there, like NAN, Pega, or APNs. Yeah, so that restrict my flexibility to implement what I want, especially my product selling point, or rather the value proposition is we want to offer the integrations for all the existing WG products. So if I'm to build on top of NAN or those Pega, I'm pretty sure I'm going to be very limited. Yeah. So, and of course, plus the durability, which I think some of you that are familiar with NAN doesn't really provide that. Yeah. Sorry, what was your first question again?
The first question was basically, if we were to do a like for like comparison and apples to apples comparison for Temporal, what other options would there be? Of course, I know you've already explained that there wouldn't be anything better, but just a general question for yourself.
I think we considered a few, but one of the things was that Temporal allows us to, the server is in Singapore, so some of the government restrictions, if you want to try to have a cloud server outside of Singapore, it's going to be very hard to get the approval for it. Yeah.
I mean, this whole durable execution, right, as like a new programming paradigm, is almost like invented by Temporal. Our founder has been sort of in this space iterated for 20 years. One of our co-founders actually built Amazon SQS. That was like 20 years ago. So since then, this whole idea of durable execution, asynchronous, like distributed, like orchestration, has been kind of iterated. And to this point that I would say like Temporal is probably one of the first. There is open source like Cadence, which is used at Uber, which is what Temporal is based off. It was also built by our co-founder. So this is kind of almost like the first kind of proven technologies that got this durable thing eventually coined, like it's kind of proven, battle tested, like powering some of the most mission critical applications out there. So I personally built something similar in the past. If you're familiar with like the whole idea behind Temporal is like event source, right? So you treat the event as a source of truth for your application, but it's pretty hard to build event source system, pretty hard to make it scale. I've been there, and I saw Temporal. They basically democratized that architecture, that pattern. So yeah, hopefully that kind of answers your question. So we have people build that in-house, but it's a lot of effort.
Okay, I have a question here. Okay, my question is for Temporal. So it seems like the server is taking on a lot of responsibility to ensure this durable execution. So I'm wondering what's the quality of service like for Temporal to their customers, QoS
The quality of the
service. Yeah.
service.
Yeah.
Wow, that's a big question. So, we're a SaaS company. Our value proposition is reliability, right? So it would defeat all the purpose if Temporal has outage every second day. So we, out of the box, we give you like a 3 nines, and then if you have replication, we give you like 4 nines contractually. But if you look at last year's stats, I'm not sure if it's like public. Now I'm gonna make it public. We actually achieved like 99.9997 global availability. So yeah, that's sort of our promise. That's what we guarantee to the customers. We have, like for example, OpenAI, one of our customers. It's been used at internet scale, and it's a lot of the money movement when you check out, whether it's from your phone or check out from the e-commerce website. That transaction is a good chance is powered by Temporal. Used a lot by the banks and fintechs. So yeah, so I mean the server takes on a lot of responsibility, but we're making it rock solid so far. Yeah.
So maybe one more question from myself.
Yeah.
So what's the business model, if you can share?
Temporal is an open source company, right? So that's why it's like everyone's encouraged to kind of visit the website and download the kind of the local server and play and try with it. Like it's an MIT license, you can host Temporal yourself. That's fine. The business model of Temporal is like we're a consumption-based business. So you basically interact with Temporal server through making transactions, and we charge you like 1 million transaction per dollar amount. So that's, sorry?
How is it being charged? What's the unit of, what's the cost?
The unit is like almost like a transaction. So every time you schedule activity, remember the wrapper that wraps the activity, which kind of run an API behind. So that's a transaction, that's an action. So we charge per million actions. Yeah, it's like a dollar amount for that, but it varies a little bit, depending on the volume. Yeah.
Hello. A colleague of mine had the opportunity to work with Temporal, introduce it into an enterprise environment, dozens of existing services of all ages, between few months and, I don't know, decades. He used the word intrusive a little bit. Tao, you mentioned a new paradigm.
Yeah.
So some of the architects, the senior developers, they felt, whoa, we have to change everything if we want to roll that out all at once. So maybe also from all three, any best practices, any recommendations if we are not on a green field, but on a very, very brown field?
Do you want to make a start? You're the adopted Temporal recently.
Best practices. I think for Opus, because we are a platform provider, so we try to plan for the worst scenarios. Like we know that because our main customers or the users are actually our public officers working for governments, so we know that okay, if they're going to use our system, roughly what is the amount of users are going to use the systems. We try to plan for the worst, like how many kind of workflows are going to be executed. So we actually started doing the load test at very early phase. Yeah, because when using Temporal, there's a lot of things, there's a lot of figures that you can fine tune, there's a lot of thresholds, there's a lot of timeout variables that can play with, and sometimes, they do recommend some of the recommended values, but all based on what you are building for, what kind of infra are you using on. So it's best that you do your own load testings and then find out what is the golden ratios that fit your requirement.
For TechBiz, because when we implement features using durable execution, the way of thinking how are we going to implement the feature shifts a bit. it shifts from between microservice to microservices, the different stage, whether it be gRPC calls between how we communicate with downstreams, how we handle the errors and things, is now shifted to how do we structure the workflow in the sense that it's a step-by-step in one single workflow or be it multiple, and that we can safely allow the durable execution to handle the retries and failures to them. And we just think about how can we use durable execution to really help us make development easier in terms of not just the retrying, but even the debugging and stuff like that. Yeah, so that was the biggest shift. Last time with multiple microservices, you can have my subscription, we have to talk to the billing we have to talk to the downstream to get certain data and things like that. We can now extract it into one single workflow. I no longer have to think the concerns between microservices at whether this particular function should belong to subscription or should belong to billing. I can let it belong to one single workflow, and then that workflow will decide which microservices to call. Yeah.
Okay, so in view of time, we'll just take one last question. Anyone? Okay.
Yeah, so Opus is only for government agencies, is it? Or is it for everyone?
Yes, for now, we are just, our target audience is still the public officers. We don't have any roadmaps how to, on releasing to the public at this point of time, but it might change. Actually, if you have interest, you can talk to my product lead, Sylvia, she's over there. Yeah. For trial? Please talk to her.
Okay, thank you. I think in view of time, we'll just close today's session. Thank you to our speakers today. Before you guys leave, could I just trouble you guys to leave us a feedback here? It's the left QR code on the left. Sorry, QR code on the left. The first 20 people who actually show us the form completion page, you'll get a freebie from us. So come up front here where my colleagues are, and then you'll get something from us. Thank you. So thank you very much for coming. Thank you. Our speakers will be around. So if you were shy and couldn't ask your question, please feel free to approach them. Thank you for coming. Thank you. Good night.